Good day, class. Today we're going to be looking at dimensions. If you remember, in our last class we looked at units. Under units, I taught you how to derive the unit of several physical quantities. So today we're going to learn how to derive the dimension of several physical quantities. Now, if you remember the fundamental quantities, we divided them into two. We have the basic fundamental quantities and we have the supplementary fundamental quantities. Now, the basic fundamental quantities are there are just three of them: mass, length, and time. And it is with this mass, length, and time that we are going to derive the dimension. So one secret you should know is that when deriving dimension, basically you are making use of mass, length, and time. You are looking out for a way to explain that how can we say mass, length, and time is related to pressure? How can we relate density to mass, length, and time? How can we relate force, acceleration, momentum to mass, length, and time? So today, like I said, I'll be teaching you how to derive the dimension of several physical quantities. Okay, so let's take the first one. Let's start with the basic. Let's start with area. Formula for area, you should know the formula: length times what? Breadth. Okay, now remember, I said in the previous class that that length, breadth, height, width, distance, and displacement, they are all seen as length. Their dimension is length, then their unit is meter. Length, breadth, height, width, distance, displacement, even radius has unit as meter, has dimension as what? Length. So today, anywhere we see length, breadth, we see it as what? Length. So this gives us L times what? L, which is L raised to the power what? 2. Let's take number 2. Let's take volume. Formula for volume is length times breadth times height. Okay, that gives us L times L times L, which is what? L raised to the power 3. Number 3, let's take density. Formula for density you should know is mass over volume. Dimension for mass is what? M over dimension for volume is L raised to the power 3, which we derive here. So from your basic mathematics, it goes up. We have L raised to the power minus 3. Number 4, let's take speed. Speed, formula for speed is distance over time. Dimension for distance is still length. We said that earlier, over what? Time. So this goes up, becomes Lt raised to the power minus 1. If we have two t's here, it will be raised to the power minus 2. Okay, let's take number 5. Let's take velocity. Formula for velocity is displacement over time. Difference between distance and displacement: distance has no specific direction, displacement has a specific direction. So distance is a scalar quantity, displacement is a vector quantity. That's by the way. Okay, so this displacement has dimension as length over t. So we have this Lt raised to the power minus 1. You see that they have the same, so they have the same unit also. Number 6, let us look at acceleration. Formula for acceleration is velocity over time. Okay, we have derived the dimension for velocity, Lt raised to the power minus 1, all over t here. So if we break this one down, remember velocity originally is L over t times this our t here, 1 over t. That gives us what? L over t raised to the power 2. Okay, so if we break that down, acceleration, dimension for acceleration becomes Lt raised to the power minus 2. We have two t's down here. Alright, number 7, let us look at force. Formula for force is mass times acceleration. Okay, mass, dimension for mass is mass, m, times dimension for acceleration is Lt raised to the power minus 2. Okay, that gives us the dimension for force as Lt raised to the power minus 2. Okay, let's look at some more. Okay, let us look at number 8. Let's look at momentum. Formula for momentum is mass times velocity. Okay, dimension for mass is m times dimension for velocity is Lt raised to the power minus 1. Okay, that gives us dimension for momentum as mLt raised to the power minus 1. Number 9, let us look at work. Work. Formula for work is force times distance. Okay, dimension for force, we have done that here, is mLt raised to the power minus 2 times dimension for distance is L. Okay, if we do this L here, we multiply this L here, so we have m L squared t raised to the power minus 2. Okay, number 10, let us look at work. Work has the same dimension as moment, so we are not going to be looking at moment because moment is also force times perpendicular distance, so but they have the same dimension.